and we automatically raise and lower clocks in real time based on hardware monitoring technology. So effectively, that means we're going to give you the fastest performance at every instant inside of a game. And it's actually very cool. I'll spend a little bit of time later talking about how that works.
Okay.
We also, you'll note, are 6 and 6 pins. So the peak power of the GTX 680 is only 195 watts. So what that's going to do is allow you to use, you know, a little bit less expensive power supply. You can see it's 2 6s. Oops. 2 6s. And it also lets your room be a little bit cooler when you're gaming. With the highest performance GPU, it's really not that hot in terms of power.
Now, one of the things I like about that is that in the software, when we get into the overclocking discussion we're going to have, is you can still push above that 195.
Absolutely.
Right, and it's fairly easy to do. Anything else on here? So we've talked about PCI Express 3.0. Any kind of major differences there? Is it just a checkbox at this point still?
Yeah, PCI Express 3.0 for our GPUs going forward is going to be pretty much a checkbox item. It does improve the performance in some benchmarks and in some games, but you know the truth is technology is going to march along, and over time the chipset infrastructure and the PC infrastructure will take advantage of it.
DX 11.1?
DX 11.1.
Okay, well, that was one of our first questions in there. So let's go ahead and switch over our inputs. Oh, you want to?
Last one. This is just a slight dig.
On the power connections again.
On the power connections. So you can see down here, the 7970 and the GTX 580 had an 8 and a 6 because those two products consumed 250 watts when you're gaming. The GTX 680 has both higher performance and lower power using 2 6s at 195 watts. So we say that's a new class of enthusiast GPU. And I hope that your viewers are really looking forward to getting that class of performance at that power level.
Yeah, I think it'll be. I think it'll be good. So,
awesome.
We'll go through your performance stuff first. This is what you know. Obviously,
this is all NVIDIA.
This is all NVIDIA only. So everybody who's watching, you know, the general will take anything that NVIDIA says with a grain of salt.
Although I never lie. So do I ever lie? Do I ever lie?
Tom doesn't lie. Tom doesn't lie. That's why we invite Tom over as opposed to anybody else. Is because we trust Tom.
Thank you, Ryan. Thank you. So this is a pretty cool chart. What it's showing you is versus our own cards, GTX 580 versus GTX 680. And what you'll see is that the performance per watt has dramatically improved, something between 30 and 60% performance per watt improvement. And that's in one generation. That's really unheard of. So now with Kepler, we're able to get higher performance and much better perf per watt, which results in this just great experience. Now, to basically take a swat at our competition, this is now showing direct performance heads to head. This is, I believe, 19 by 10, and you'll see in just a different collection of games, we're going to beat 7970 by somewhere between 10 and 40 to 50%. So it's a nice win versus AMD 7970. Now, that's just NVIDIA's view of performance, and I really think we should turn it over to Ryan and maybe pull up what you saw.
Okay, let me see this.
You want me to switch the display?
Yeah, go ahead and switch the display.
Okay, I think it's HDMI 4. All right, there you are.
Okay, so actually I just realized since we don't have a camera pointed at this anymore, we're using inputs. We won't be able to really see that on any. Let's make sure we don't have any of that. Yeah. So, but we can give a general overview here. Obviously, if you're watching this, I hope you have been to PCPer.com and you have already read the GTX 680 review. This is why we didn't do it at 9 o'clock. We wanted to give people a little time to read the article, kind of digest it, come up with their own questions, because that's what we're going to do. Is we're going to, after our discussion, we're going to do a lot of Q&A. Let people ask what they want to ask. Nothing off the table, right? They can ask whatever they want. Doesn't mean Tom will answer it necessarily.
I may say I don't know,
but it'll be available there.
I may say I don't want to answer.
So, you know, one of the things that I had trouble with writing this article was in the architectural differences between Kepler and Fermi. And in truth, in my discussions at the Editor's Day and that stuff, is there's not a whole lot that's really no single big item that is changed, but there are many little items. The biggest item probably is the move from an SM, a symmetric multiprocessor to an SMX, which is just a next generation of it. It's extra, right? And so you can see, if you look at this, you're looking at 192 cores per SMX as opposed to the 32 cores per SM that we had before. Now, that being said, we have half as many SMXs as we did SMs. So, you know, we're seeing 1,536 total CUDA cores, stream processors, whatever you're going to call them, compared to 512 CUDA cores in the 580. Now, I think a lot of people, and maybe through some unfortunate leaks on maybe reseller sites or something like that, are thinking that the 3 times as many shaders running at 1,000 megahertz, a gigahertz clock speed or higher, you're talking 3 times performance. But that's not the case.
No, that's not the case.
And that is because there is no more hot clock. There's no more. We're used to seeing 800 megahertz core clock, 1600 megahertz shader clock, and that's no longer the case, right?
That's true. That's true. Effectively, what we've done with Kepler is organize it more for power efficiency. So we're not going to be running the clock super fast on those tiny little blocks. It actually turns out to be much more power efficient to slow the clocks down and to put more shaders down. So effectively, we've traded off area to some degree for power efficiency. But the net result is you get higher performance and much lower power and much higher performance per watt. Right? That's the way to think about it.
How much of that kind of design decision is really focused on, like, obviously you're able to get good performance out of this card, you're able to get great performance out of this card, but is that really something that like is driven from the mobile side? We really need to have power efficiency on our mobile GPUs as opposed to on the desktop GPUs where it's maybe not as important?
You know what, I think it's definitely critical on the mobile, so that technology has to be invented. But on desktop, we feel like we were not world-class last time, right? Fermi was not world-class. And one thing NVIDIA is excellent at is taking honest feedback, intellectual honesty within ourselves, and then getting better. And honestly, the biggest thing we needed to focus on was performance per watt. And I'm really excited that the architects, it's sort of in the DNA of the architecture team to now optimize performance per watt. And there's a million things they've done to make it better.
You didn't want to be the big hot chip anymore.
We want to be the delightful chip. the one that you can have under your desk and be delighted.
Right, understand. There's a lot more detail on the first page of our review that kind of goes over some of the things that have changed. Some of the scheduling has moved from hardware to software, which I thought was an interesting move. The one thing that I think maybe some people might misunderstand, the Polymorph 2.0 engine, which is where your tessellation, your what else is included in there, your transform, basically all the geometry side of things. They say it's doubled in performance, but you have half as many of them in units. So in theory, the tessellation performance remains pretty much the same, clock for clock.
Still kicks ass relative to our competition, is what you mean.
Yes. So if you look at this graph on the page there, you'll see one thing I was curious is this must be some kind of trade-off that I don't completely grasp. At the lower expansion factors, 1, 3, 5, 7, 9, you actually admit that you are a little bit slower than the 7970. Right. But once you get past that, it seems to obviously ramps up. Yeah. So there's the issue is there's differing opinions from NVIDIA and AMD on which expansion factors are most important to the consumer. It's true. Is it obviously, is your thought that this is going to be more important in the future, and this is maybe a little bit more important today, like in this range? Or
I'm thinking this is all up to individual users when you look at it. Down here, things still look very flat, right? The geometry that you're visualizing when you're walking around a game, it just doesn't give you that sort of experience of a realistic world. But as you move to this side of the graph over here,
oops,
then over here, that's when you start seeing like the little nodules on the leaves and little veins on the leaves. So it's really up to the users. I know we do great on tessellation because we're sort of driving the infrastructure for gaming. And if we don't do a fantastic job on tessellation, then games will never adopt it. So that's the way we look at it. We're kind of the leader for gaming, and we're going to make the investment, and we're going to help developers and our content guys take advantage of it.
Have you guys seen tessellation pick up as much as you had expected or as hoped to? In my opinion, I don't think I have.
Yeah, I think it takes time. And really what's interesting is it's not just tessellation, it's the artistic process needs to start thinking more about
the tools that create that
right?
Stuff.
And then once our artists understand that you can have really beautiful geometry and that geometry will carry forward into the game, that's when we're going to start seeing, kind of the knee in the curve. It has to deliver a better experience.
Gotcha.
And to deliver a better experience, that takes the content guys to do the right stuff.
Fair enough. Also kind of interesting, world's first 6 gigabit per second. This is 1500 megahertz clock speed.
Beautiful. I know the team is particularly proud of this.
At the editor's day, they fawned over this image quite a bit, actually.
Do you know what this shows? I mean, this is really crazy.
It shows that it works and stays within tolerances, essentially.
These are called eyes, right? And what you're looking at all these little green lines are individual samples of the wires moving around. And so the thing you'll note with the way the memory interface works, it's differential. And the differential creates these little eyes, right? Because that's where the actual data is. Sometimes the data is up and down, and sometimes the data is like this, right? But you should never see a signal in the middle. That would mean that you're losing margin. And as you get faster and faster, these eyes kind of collapse on each other. So that's how that's why this chart is important, because you have very well-defined eyes. It means that even running at 6 gigabits, you can see there's some margin. And as a matter of fact, if you get yourself a GTX 680, go ahead and play with the memory overclocking. So far, what I've seen is very easy to get it up to, say, 6.8 gigabits. So 6.8 gigabit transfers. Really? Yeah. Without, and maybe we'll show it.
Okay.
Because
we like to do stuff live. We'll see.
Yeah. Let's get in there and we'll play around with it. So memory transfers are it's one of the things that the team is truly and rightfully proud of.
Also new, the NVIDIA encoding engine. This is interesting in my opinion. It is a fixed function section of the chip that is basically for video encoding, 1080p encoding, 4 to 8x time. In my opinion, this is a response to Intel's Quick Sync on Sandy Bridge. And is it faster than that? Is it about the same?
It's about the same.
Okay.
It's about the same as the performance on transcoding on Sandy Bridge.
Now they're saying single-digit watts versus tens of watts.
I don't have the numbers directly in front of me, so I don't want to comment on Sandy Bridge's power consumption for transcode.
I was told that the NVIDIA encoder will work with the GPU physically powered off, like
not doing anything.
Correct.
It will work at desktop, right? So at desktop, the GPU is still doing stuff, but it's not it's not doing 3D rendering.
I think I heard that it will work actually when it's powered off, like in a mobile form factor, like when Optimus comes in and kind of cuts that.
Yeah,
it will still be able to use that.
Well, that's awesome. That's news to me.
Well, I'm glad we can.
I'm glad I'm learning.
So we talked about the display support already. Yeah. We already talked about display support. NVIDIA Surround, 3D Vision Surround on a single GPU, well needed. Behind schedule, but good. It's there. It works. We did some performance testing. We'll show you guys some of that. DisplayPort 1.2, HDMI 1.4a, 4K monitor support. Why didn't you bring one of those with you?
Well, they're not really available in volume production yet. So if you look at
they're also kind of expensive.
They are a little expensive, like $30,000 or something stupid. But I do think that you're going to see higher resolution panels become more common because they really do offer a great experience. And when they start showing up, we'll definitely be working with them.
Somebody told me, I think it was at Editor's Day, one of the vendors was saying that they were very confident that we were going to see 27-inch, 2560 by 1440 displays under $500.
This year?
This year.
Wow.
Which I think would be a big...
That'd be awesome.
It'd be beneficial to you guys. You guys want to sell higher-end GPUs, higher resolution.
We love higher resolution.
To sell that. So, and this is a photo of
the die shot.
The die.
Nice.
Now I don't know how much of this is faked or fudged or anything like that.
That is a real die, and the only thing that's faked is the colors.
But I like that. I think that makes it artistic.
It's trying to highlight the different function units, right? So there are 8 SMs, right?
Okay. All right.
Yeah. See. 1, 2, 3, 4, 5.
What does it look like when it's not artificially colored?
Well, right now, if it's not artificially colored, it has a metal can on top of it. And then after you take the can off, all you see is the backside of a die. So what you actually have to do is take the die and not mount it. And then you have to shave it because there's lots of metal layers that are just balls that are solder joints. So what this actually is one of these partially processed wafers that are designed just to generate this image.
That's pretty cool.
Yeah.
3.5 billion transistors.
It's pretty good.
It's a lot of transistors. 28 nanometer,
small die.
TSMC. We won't necessarily get into all of the potential issues with capacity and yields and all that kind of stuff.
All I can say is at launch, we're very, very happy with the volume that we're servicing. So I have
we heard before we started this that they might be sold out at an hour. So if you're listening to this and you want one,
they're selling quick.
You might want to do that. Actually, we looked at Newegg earlier. They were sold out. Who had some?
I think it was Tiger.
Tiger Direct still had several in stock.
Maybe Amazon.
Maybe Amazon, yeah.
But again, if you're interested in a GTX 680, run out, buy now. Yeah.
Well, there you go. So I think before we talk about the features, maybe we talk about the performance.
Okay.
And then we talk about what features bring that performance. So this way we'll kind of go through that. So we have our normal allotment of games that we test: Battlefield, Skyrim, Dirt 3. Battlefield 3 is one of the most important ones. This is a very popular game, obviously. They love Battlefield 3. It tends to be pretty hard on GPUs. We're running at ultra settings, 1080p, 2560. If you want to go to the site, you can watch. You can watch the video. This is exactly how we test. We're very proud of this. We show you exactly where we're testing the game. You can reproduce it your own fashion.
When you run the test, you have to mouse through it every time.
We're manually playing this game each time. 180 seconds, 3 times per resolution, per card. makes a very unhappy GPU tester. It makes Battlefield 3 a lot less fun.
Yeah, but it does give you a kind of real-world gameplay, right?
Yes, and that's exactly what we're trying to get. For games that don't have a benchmark solution that we think is very accurate, we do this. So 1680 by 1050, low resolution, maybe not necessarily the resolution you want to pick if you're going to buy a $500 video card, but it's the 680 is ahead of the 7970 there. Again, these are hard to see on the live stream, so we'll scroll through them fast. 1080p past it, and 2560 by 1600, again, a little bit past it. And then we did our 3-panel testing as well, 5760 by 1080. And pretty even there between the 680 and the 7970,
That's cool.
7950.
So it's the first time I've seen this data, of course, but I like to see the fact that we have an across-the-board win for everything except multi-display, and it's pretty much a tie multi-display.
Yes.
That's cool.
It's pretty good. One of the other games that I think, Skyrim has a lot of performance improvements that I think come with the 300 driver, the 300 series driver as well. So the 580 results in these numbers are not on the 300 driver. We didn't have time to run them with 300 driver.
So you're going to see bigger gaps between.
So, but what you focus on the 680 versus the 7900 cards. Again, we have a video where you can watch us
and this is your
run through Whiterun. This is actually in the city of Whiterun in Skyrim. I really wish, rather than sitting here doing work, I would be playing this.
How much time have you put into Skyrim, personally?
I tell you what, when it's probably about 65 hours, which is a lot, but it's not that much compared to a lot of people out there.
No.
Basically, since January, since after CES, I haven't been able to play because you guys keep releasing products and stuff.
You gotta get yourself off.
AMD, the notorious one for that. But you can see here the dramatic differences in even at 1680 by 1050 between the 680 and 7970. We're talking about almost double.
Wow.
Now that decreases a little bit as the resolution goes up.
Yep.
But still 80 versus 58, performance-wise, is pretty good.
Pretty substantial.
So we'll see the kind of driver fixes they come up with. And then again at the surround versus Eyefinity test, talking 53 frames per second versus 45.
Wow.
So still,
that's great.
Still pretty good win.
That's really good.
Dirt 3 is a big NVIDIA win. Batman 680 wins again. And Metro 2033 is the only game where we saw a definitive advantage to the 7970.
I'm surprised by that.
I was surprised too because Metro 2033 was an NVIDIA way it's meant to be played title.
It might be the way you ran it. Let's take a look at what level did you run? Or did you run the benchmark?
We were running the benchmark on this, and this has been the case for a couple of generations, not a couple of generations, but let's say since the 7000 cards have come out, really, which is interesting because Dirt 3 was an AMD kind of game, right?
It's weird that we do better on Dirt 3 now.
And it's swapped, yes.
I don't quite get that.
And I think your driver teams had a little optimization win there.
I love our driver team, but we need to take another look at Metro 2033.
Yeah, because I mean, there's another game coming out. I forget, is it Metro 2034? Well, I don't remember what it's called.
I can't comment on future games.
But we assume it will use the same engine, or at least a slightly modified engine, so these numbers will become important again later this year when that game comes out.
Sure.
And then Deus Ex was kind of a wash either way. 3D Mark 11, big win for the GTX 680 and Unigine as well. We don't put as much stock into synthetics as we do the real games, but they're useful indicators for the game, if nothing else. So
what about this one? I want to see this one. Power consumption.
Power consumption. Okay, yeah, you guys are really.
Come on,
you guys
baby.
are proud of this.
Baby.
You guys are proud of this one. So,
and
in general,
we should be.
In general, let's go into the past. Let's talk about the 480. And the 580.
Okay.
Very fast GPUs.
Awesome.
But they were
warmer.
They were warmer, and they used a lot of power. And in fact, you can look at this graph here. The GTX 680 actually uses 60 watts less power than the 580.
Yes.
While running significantly faster.
Yes,
that's impressive.
That's the way to think about it. You get more performance than a 580 with much less power. And if you had a 590 on here, you'd see the performance is actually not that far off of 590.
Oh, really?
At much lower power.
Much lower power.
Much lower power.
Compared to the 7970 from AMD, this is interesting. This may be the first time we've ever been able to say this. The NVIDIA card is actually about 30 watts less, uses about 30 watts less power than 7970, and it outperforms it.
It's awesome.
So it is. I think I say specifically in the article, it hasn't been often or ever that we've been able to say that NVIDIA has both the most power efficient and the highest performance.
I got to tell you, I'm definitely going to have this in my house for sure. I'm excited about it. Our engineering team should be proud, and any of the engineers that are watching this, awesome. Everybody loves.
They did a good job.
Yeah.
Temperatures are kind of even here, I'll say. What was interesting to me in our testing is that this we hit about 81 to 83 C, but it was constant.
Yeah.
We didn't have any spikes,
yeah,
right? Which I think has to do with the GPU boost technology that we'll talk about here in just a second.
Also, I think the thing you're missing on this chart is I'd like to see acoustics at these different temperature levels, because I think they're substantially different.
You know what? I have those.
You do?
But they're not on the story.
Like right next to there, right?
I will add that, and when we start the other demos, I'll see if I can bring up that graph, because I know it's uploaded. I know it's there.
Cool.
I have it. So, so overall, let's see, $499, $499 if you can find them. And I'm glad to see that Newegg and those guys were selling them at $599, maybe $509.
Yeah.
They weren't jacking up the price.
You mean $499?
Yes.
$499, $505, not $600, $700.
Correct.
Right?
Correct. So I guess at the editor's day, when we learned all about the GPU and you brought all the media in, including mobile and desktop guys, and we said, sounds great. What are you going to sell it for?
Right.
And everybody at NVIDIA would say, we'll tell you later. And that's, as a reviewer, that's frustrating because it's hard to frame things when you're writing and testing.
But now that you know.
But now that we know, it's actually pretty good. It's really good. Let's
stay with the second one.
But I would say what probably the people in our chat room, the people that are listening to the stream, are maybe they're glad that you guys. I think you could have released it at $599.
Yeah.
Based on the price of the 7970 still being $549, and people would have been like, it's faster and it runs more efficient. Okay.
It's got some cool features.
But it would continue this kind of trend that I personally don't like, which is
graphics cards getting more expensive.
More expensive again, right? You know, and the days of $699, I was hoping were kind of behind us, so we'll see how that works out. But $499 is still high. It's still an expensive card. It's still an enthusiast
680 class, right?
It is. Yes, it is still an enthusiast class card, but you undercut the competition, which is something that NVIDIA is not traditionally known for doing.
That's right.
That is something that AMD had traditionally done up until the 7000 series launch, is that they have a good part, but they still undercut just so they get that extra bit of excitement and push on their card.
It's not normally our desire to be the lowest priced GPU, because we're a premium GPU, right? Our GPU has better drivers, we have better game support, and at the same performance, I would expect us to be more expensive.
Okay. So I'm here at the GPU Boost page.
Okay.
So maybe you go ahead rather than try to show these graphs, because this is
demos, right?
Yeah.
All right. So we're going to cut back to my charts, and we're going to try to see if we can
stop, Gabby, stop.
PC. Yeah, that's what.
Wait, we've got them up right here already, I think.
Oh.
Is that what you're looking for?
Yeah. So let me see if I got them up here. Yeah. Okay.
There we go.
Great.
Okay.
So this was the performance chart I saw. You know, Ryan showed some similar stuff, and depends on the game you run, the resolution, you're going to get different results. But this is a solid win for us. And again, if you count perf per watt, then it's a solid. I don't know what's the technical term for when it's bigger of a win. Perf per watt, it's like an ass kicking. Can you say ass kicking?
Yeah, you can say that.
Okay. And part of what lets us get to that performance level is this new technology called GPU Boost, which automatically boosts clocks and speeds for performance. Okay, so I try to explain this, and it can be confusing, so we'll go slow. But the way to think about it is, if you were to run at a fixed clock, power would vary from some game that's your max performance power to another game which is min performance power. So you can point at that side and I'll point at this side.
Yes, here we have this.
Okay. Now, this happens on every GPU. So if you just ran 580 or 480 or 7970, they all run at different powers. Now, the way to think of it is...
Now, go back to that one. In my article, I said that this has kind of been done by both AMD and NVIDIA already for very specific applications. FurMark, OCCT.
Yes.
Right. That you used to have to add FurMark to this, which maybe was higher power, and OCCT, which is higher power, and then you would set clocks that way.
Exactly.
So in the last generation, you guys started this trend by specifically looking for those applications and saying, you know what, we're not going to let you influence our performance.
That is a very good point. So if we extended this chart and drew one more bar, it would be higher than our power target for the board. That might have been FurMark.
Right.
And what would actually happen with FurMark is it would run at lower clocks. Right, we would detect it, and we would run at below stock clocks. So you're right that we've kind of had similar technology, but it was very much app-based, and it was very much sort of think of it as a beta version of GPU Boost.
Okay.
So now what we're going to do is we're going to look at this this fact, which is games have different power, and then we're going to look at the lowest power game and say that's an opportunity, because what's happening is the GPU is running at very low power. and it could run higher, meaning that we could consume more power and convert that into performance. So when we use that extra power, we can effectively get higher clocks, right? So we dynamically take that power and we ramp clocks.
So this is power headroom that the GPU has, based on what you set your power target as on the most demanding game.
Exactly.
Let's say this is what's one of, like 3D Mark 11.
3D Mark 11
would be one of these.
Is an example.
And let's say what would be one down here?
Battlefield 3.
Battlefield 3. Surprisingly, doesn't
have a lot of power per frame.
Okay. So you have that what you're calling boost opportunity there, which allows you to do what?
Higher clocks.
Next slide.
So what we do now, I've changed from power to clock. Right now I'm showing you clock. And remember, the baseline was every game ran at the same clock level. And what's now going to happen is that different games are going to run at higher clocks depending on the specific behavior of the game. Now this is a simplification because we actually do this on every frame. So we're actually sampling every 100 milliseconds or so, and we're dialing in exactly the right voltage and frequency. So while I'm showing this variation per game, you should really think of it as lots of variation inside the game. Okay? So I think the best way to show this is a live demo. Okay, now live demo streaming sounds like a great plan.
We'll see how this goes, right? So let's see. So okay, that's the main.
So I'll leave this here.
Okay.
And then I will. I'm going to go ahead and explain this. Now this is a new tool from our friends at EVGA, and it's called Precision X, and it's available today. I think hopefully Jacob and Joe have it online.
I hope so.
I would assume they do.
I hope so.
But what this does is shows you your current clock on this little speedometer. So right now we're running at 549 megahertz, which is sort of our desktop idle clock. And it also shows you your voltage. You're running at 987 millivolts, which is just a little bit lower than a volt. And we've got some sliders I'll talk about in a little bit, but we've got two little indicators here. The blue one is your base clock. Now the base clock, think of it as a guaranteed worst case clock. So we're not going to lower the clock below the base clock unless there's some kind of thermal throttling going on. So if you take a GTX 680, you put it in an oven, you close the intakes or whatever, then we're going to start getting hot and we're going to go below that number. But in normal operation, you're going to see base clock or higher. The second number in red here is the boost clock. Now the boost clock is another spec, and that's set at 1058 for GTX 680. And what that boost spec means is that's your typical clock. So when you're running typical games, when you're running in a typical environment, you're going to get that clock or higher.
Now, typical is a very vague term.
Yes.
Do you have a specific game that you consider typical use case, typical boost clock that you just aren't telling us?
We do have a very rigorous testing process that we do internal, and we really haven't released that information. But the way to think of it as sort of room temperature is typical. So when you're verifying base clock, that's at elevated temperatures. When you're verifying boost clock, that's at room temperature.
Right.
And also, typical is not worst case TDP. It's not the worst case power. It's more like 70% power. So if you're running a game with a fixed clock, it would be more at 70%. Okay. So boost really is typical. You'll see it pretty much all the time when you run a normal game.
Okay.
Okay. Now, one thing that's really important is boost is not the peak clock. So we can go higher than boost, and we will go higher than boost a lot of the time based on what's going on inside the game and the power monitoring. Okay. So now with this little guy, I can open up a little kind of like a graph, and what I'm going to do is run Battlefield 3. Okay. So let's switch over to the Battlefield 3 page. Let me kind of do this thing. And that monitor is just going to do its thing, and we're going to run Battlefield 3 in full screen. Okay, so where's Battlefield 3?
So we should say we're able to show the monitoring and the individual game at the same time. I'm not sure how well this is going to show up on the stream. We kind of have a side-by-side up right here.
Okay.
Which will hit offline mode just for this case.
Okay,
and then it's on the... what'd you do?
I've got milk water on it, so...
Don't say it out loud, though. That would be great if you wouldn't say my password out loud.
Is that a big or a little?
It's little big, little big.
Little big, okay. Come on, baby. Come on.
I don't even.
Yeah.
Even when I don't have a network connection attached, it still makes me do that when we test offline.
Can we ask the Dice guys while we're streaming any Dice guys on? Please give us a flag to skip the movie. That would be so nice.
Yeah, that would save us a lot of time.
I mean,
yeah.
What do you want to talk about?
Well, let's see. We've got lots of time. I see you've made our EVGA Precision OSD
Purple.
Purple.
Does that show up now in the stream now that it's purple?
Yeah, so it kind of does.
Oh yeah? Okay.
Right there.
Okay, that's the overlay.
So let me know in the chat room, guys, if this side-by-side even kind of works at all. Like, can you see? In my preview, it's hard to see.
Yeah, the boost on the left looks hard to see.
Yeah. It may look better on their end, and I don't want to stream here while we're doing stuff as well. So here it is. We're loading it up. So here we'll take that down. Well, we're going through our menus. So, how do you like Kentucky?
You know what? I love Kentucky. I've been here now for a day and a half, and staying downtown. This downtown is beautiful Cincinnati. What I did not know is that Kentucky is right next to Ohio, and that sure enough, Cincinnati is right next to Kentucky. I had no idea.
You didn't know when you landed at the Cincinnati airport you were landing in Kentucky.
I did not know.
Literally 10 minutes from this office, and then you decided we got a hotel.
I did, and we had a nice dinner last night. I understand that Kelly got her hair highlighted. So Kelly, if you're watching,
she better not be watching. She's supposed to be at work.
I have not yet seen the hair picture. Okay, I'm looking for that. All right, so let's get that posted, please. And here we are. So just in terms of showing you what we're running, we're on video now, and everything is on Ultra, and we're running at 19 by 10. Okay?
Yep. We can run higher, but this is a requirement for us to stream it, capture cards, all that kind of stuff.
Okay, now what we're going to be looking for before I start is...
Go to well,
I think we just...
Yeah, okay. Let's do resume.
Okay, now I'm not going to try to win. I'm just basically going to show you what the game does with the clocks.
He's not going to try because he can't.
Yeah, I can, but I'm getting old and tired, and we'll see. All right, I'm going to bring it. I'm bringing it.
All right. I set it on easy for you.
Did you?
I don't know.
Nice.
So we'll show it up here a little bit, but the OSD, that's not a new feature necessarily for EVGA Precision, right? The on-screen display.
No,
but it is giving you new information.
Yep.
Clock speed, percentage of utilization of the GPU, that type of thing. Hey, look at that! It's working on the stream.
Can you see it on the stream? Yeah.
We're not even crashing.
Yeah,
it's good
all
news.
Good. All right, I'm waiting for some bad guys.
Got to go over to your right there.
I think they're going to come through here.
Yeah.
Okay, so what we're really doing, though, is generating clock information. So let's go ahead and pause this and tab out.
What are you trying to do? You want to get to this?
I want to get to that. Yeah, there we go. And let's switch this screen over to that other thing.
Nope, two. Yep.
Okay. So now on the monitor, let's talk about what we saw. Okay, so let me get the mouse down here. Okay, and
pause that.
A cool thing about the monitor is you can pause it. Now, for those of you that can't see it, this is the region of time when we were in the game. Okay, and we're monitoring a bunch of cool things here. The first thing up top here, that is the clock, and you can see the clock was running pretty stable at 1110. So our base clock was 1005. And now we're running at 1110, so it's clearly getting a boost right out of the get-go for Battlefield 3. Now down here, I'm showing you the power, which is also new. We didn't normally report power in our NVAPI.
This is not power by wattage. This is power as a percentage of the TDP,
right? So
which is 195 stock.
Right. So if you kind of did some math, you could get to what power number this is. But basically, it's running at about 90%, and it varies based on frame. That's why this is able to get that high. Right?
That's what I found most interesting is how variable it was, even in the same game, between scenes, between everything that's going on.
Yep, it's very, very variable. Very variable. And down here, we're showing GPU utilization. So we're actually getting pretty high utilization, but the power is basically not being pegged, and you can see your frame rate changing. So this is a great example of running a real game and getting a very solid, boost at up to 1110. Okay. So let's get out of here and go back to the main screen.
We'll go back to the game.
Yeah, that's what I'm going to try to do. Let's see. Okay, and now I'm going to...
Next time you come, we'll have a fancier system for changing
these. It's pretty cool. Let's get out of here. Okay, and now I want to go back to the slides to explain a little bit of what I saw.
Okay. So
this is probably editing.
So what was the frequency we saw there?
1110.
Okay. Right? 1.11 gigahertz is what the GPU was running at while you were playing Battlefield 3.
Absolutely.
Base settings.
Solid as a rock.
Installed the drivers, installed precision. Now there's options. We're going to change the precision later, show the overclocking and that kind of stuff. But that is 110 megahertz or so over the base clock.
Right, and that's not overclocking. So I'll explain this in a little bit. The difference between overclocking and boost is substantial. So now we're back to the slides. turn theater mode on. Wow. Okay.
That doesn't sound helpful.
It doesn't sound like it's something you would normally want.
HDMI 2.
Okay. Back to the slides. Oh, we're back to the beginning. So here we go. Clicking through here.
You could right click and go through that way if you want. Select slide.
Okay. Right click. There we go. Right click. Select slide. And we want to go to GPU Boost. We just talked about this. And that's what happened right here, right? That was basically Battlefield 3. This was 1006, and this was effectively 1110.
Okay.
Now, what did you see? This is where it gets a little bit complicated. This is the way graphics clocks used to work, right? There was one voltage and one frequency that we would run at. For GTX 680, you could think of that as sort of like the base clock of 1006. It had to work in all conditions. It had to work in all chassis. Now, with our new technology, with GPU Boost, we no longer have one point. There's a whole collection of pre-verified, fully qualified voltage and frequency steps. This is about every 13 megahertz in clock. So what will happen is the part will automatically raise and lower its current frequency based on a lot of different algorithmic things.
This is not necessarily a linear
It's definitely not.
thing, though. Voltage to clock.
No, this is simplified. The real curve, bends over, and you get as you increase voltage, you get less and less
benefit from that.
Right.
Okay.
But the fact is that the concept is very simple. We're going to be changing our operating point in real time based on hardware monitoring.
Okay.
Okay. So what normally limits that is power. So when you're running at a stock power, there's a range that you can move up and down, and that range is basically what's my current clock based on hitting my target power.
Is this 195 watts?
Of this being this is sort of 195 watts.
Okay. Okay.
Right? And so the power will vary, and the point that you run here is always going to be 195 watts.
Okay.
But the frequency will change.
Okay.
Right? So when you overclock, you can increase it. So effectively, if you raise the power budget, and I'll show you how to do that in just a second, you would expect the operating range to move up. So it's a very cool technology. By raising the power, the clocks will automatically raise. I've had a lot of people ask me, well, if you can just raise the power and get higher performance, why didn't you do that? Why is that not stock?
That's fair.
And the reason we didn't do that is because we want stock to be just a beautiful experience. The card is basically silent when you're running stock. If you add power, then the fan's going to, on average, run a little bit louder. So that's the trade-off. It's not just performance per watt, but also acoustics versus performance. Okay. So let's do 3D Mark 11 and kind of give another demo there.
Different opinion.
And we're going to go ahead and we're just going to set. I'm going to set the power a little bit low just to make sure it does what I want. And
that's interesting. So you can actually lower it too.
Yeah, you can lower it. If I want the clocks to be really low, I can set this down to like 70.
Okay.
But for this one, I'm going to go 86, and we're going to see what happens with 3D Mark. So let me switch over to the other one, PC. Okay. And what we're going to do is now the monitor is on this side, so I'm going to bring it up. I'm going to unpause it.
Top one.
Okay. And then over here, remember that was running at 1110, and now I'm going to run 3D Mark 11 GT1. Now the difference with GT1 is effectively that it is more power intensive per frame. Okay, so let's run it. So what I would expect to see is instead of the clock boosting all the way up to 1110 and staying there, it should kind of be either at our minimum, which would be 1005, or it should be bouncing around a little bit. But let's just take, whoa, Future Mark Scanner has stopped working.
Try it again. It's probably because of our switching between displays and stuff.
You think? So does that mean it's not going to run?
Oh, maybe it is going to run.
Maybe.
Oh, okay. There we go.
Hey, thanks, Future Mark. Okay, so on this screen, we're going to show the full screen GT1, and on the other screen, we're showing the power monitor. And remember, I lowered the power to about 86%, so I would expect it to not be running at full clock rate. So what are we running at? 1005, is that right? I can't quite see it. Oh, so switch back.
Yeah, we can switch back. We can see there. We'll let them see both at the same time while we kind of describe there.
Oops, that's a PC. Let me do the other one. Input
2.
All right. So you can see GT1 is doing its thing. Oh yeah, cool. And so what you're seeing over here on the power side is that most of the time you get down to 1005. This has got a little bit of a rounding error. It says 1006. But the truth is, you never go below that base clock. And you're even able to sometimes boost up with this card. So what I'm showing you here is 3D Mark 11, a lot more power intensive, and the clocks are going to tend to come down to your base clock a lot more often. Okay, but let's come back to the tool and say, all right, I'm willing to give you more power. So first let me freeze this.
We should probably maybe, is 3D Mark 11 still running?
No, I think it's stopped. So we're going to go ahead and raise the power up to 130 and apply it.
Okay.
And then I'm going to shift back to 3D Mark. And it's PC. Okay. Now
So we have essentially told the card you are allowed to use 130% of your TDP as opposed to 195. So that takes it up to like what, 250?
Around 250.
About 250,
shorter, yeah.
which is kind of the limit of
what the
two 6-pin power connectors and a PCIe
The way to think about it is this board is designed with a higher power budget in mind.
Okay.
Right? And we actually pushed it down quite a bit to deliver excellent acoustics and a beautiful experience. But the board itself is still guaranteed to work. So there's no risk sliding the power slider. It's fully guaranteed. So if you want to play with the power slider, just kind of push it over and see what you get.
When you say guaranteed not to catch on fire, or guaranteed to be stable, or guaranteed?
Guaranteed to be stable.
Okay.
Guaranteed not to catch on fire.
Okay. I like those guarantees.
Yeah.
That's good. That's good.
All
Okay.
right, so here we go, and now we're going to run.
Okay.
So now
So
this
we've
time,
increased it to 130%.
Yep. And I'm going to switch my screen to the monitor. Okay. And I don't think I have it on big mode. I'm going to have to watch one more time. Yeah, it's going to freak out when I do this.
Doing something I don't like it.
I think 3D Mark's going to say, "You're doing something and I don't like it."
Ah.
We'll see.
Well,
Maybe not.
So running, let's see.
What do you think?
I don't know. Is it still running? Let's see. No, it didn't run.
All right, we'll go back.
Yeah.
They're smart. They are good at detecting that.
They don't like not having the focus. Is
Don't
what they're
touch
telling.
anything.
Yes.
Okay, so close this and run that. Okay, and now I'm going to go back to the other thing. And right here. Okay, now in this case, remember all I did was add power. And so I would expect the boost clock, instead of being that like low at 1005, it'll be jumping up to some higher number. So let's just see what we get.
Let's see.
Okay, the graphics test is about to start.
We love
Side by side's pretty cool.
Yeah.
All right, there we are. We're started. And now look at that. The graphics clock is, the GPU clock is at 1110, and it's moving around a little bit. And that's those little glitches down are when we get effectively a high spike on power.
What I think is interesting is you can look at the power. You can see numbers now well above 100%.
Right.
Telling you that the GPU is utilizing, and it's almost looks like there's an earthquake going on inside the PC. How dramatic the swings are in power consumption going from one to the other. It's 100 millisecond portion to one other 100 millisecond portion.
And there's a lot of things that are varying there, right? Because we're changing a lot of the internal functions based on power, and that's what the spikes are. And plus there's a little bit of hysteresis here. We're going to get better at it. This is our very first version of it, so I would expect us to be able to decrease that noise and increase the overall operating point over time. But that gives you a sense for adding power, right? When you add power to the card, you're going to run on average higher clocks.
Okay.
Okay.
But there's another slider.
There is another slider, so let's go to that. And I don't think I want to use 3D Mark. Well, I guess we could use 3D Mark for that. But let me go back to the slides. So I think I got to go over here.
Sure.
I have this highly orchestrated.
We do. We've got it down to a science here at the. If anybody's just joining us, by the way, in case you don't know what's going on, we are doing a live review. I'm Ryan Schrout, PC Perspective,
and I'm Tom Peterson with NVIDIA.
You can find us at PCPer. You find me at PCPer.com. You don't often find him there.
You won't find me there.
He's not allowed to be there. But the GTX 680 launched this morning. Reviews went live, and Tom has come out to kind of talk to you guys and answer some questions. So if you want to ask questions, you've got ideas you want to put forward, go ahead, jump into the chat room and leave them for us there. You can follow me on Twitter at Ryan Schrout and send me a message that way. We've already got several questions kind of coming in for that. Which is good to see. And let me get an update here for you. There are currently 1,038 people watching.
Hey, that's pretty good.
That's pretty good.
Yeah. How many can we support? Like another?
We can support maybe another 1,000 people.
All right,
maybe
great.
another 1,000 people.
Excellent.
We are limited. Our streaming server is limited by its 1 gigabit Ethernet connection.
It's amazing that we can do 1,000 people on a gigabit.
Yeah, we're streaming at about 600K or
600K per
so.
stream?
So we're at about 1. So okay, we're closer than that. Maybe not another 1,000, another 400, 500 people. So
It's still pretty cool.
Tell your friends to
Still
get
pretty
in
cool.
while
Get
they
in.
can. Yeah. So it's it's going well.
Yeah. All right. So this is back to what we just showed. Remember, this is the range that we would have operated at if we are at stock. And what we did was we raised power, and the clocks went up. Right. That's the first way you can overclock.
Okay.
So I just did the demo of 3D Mark 11. Now let's talk about the second way to overclock. Now in the past, this is the old way. We used to have our fixed clock. It would be fixed for all the times. But some of our partners or users would raise the voltage and raise the clock, right?
Mm-hmm.
It would consume more power, but it would be stable because they raised the voltage and raised the clock.
Right.
And then some people actually did the second thing, which is they raised the clock at the same voltage, and that is called binning. You found that you got a very, very fast GPU, and so you're able to raise the clock at the same voltage. If you think about this little picture, that's what's happening. Now, with GPU Boost, you can do exactly the same thing. So this is where we would normally operate on this little green line, right? That's our stock. We're going to be moving between base and boost and sometimes going above boost. But now you can add what we call a GPU clock offset. And if you add a GPU clock offset, what you actually do is shift this entire curve up, right? And by shifting it up, you're going to get higher clocks at every voltage. You can't turn GPU Boost off. So even if you shift the clocks up, it's still going to be, doing its little GPU Boost thing within a power range. So that's what this yellow bar shows you. It's going to be operating between some upper clock and some lower clock, all set by a power budget.
Now, what I think is important to point out that maybe I didn't understand it first until I actually got my hands on it and started playing with the stuff is that when you set the GPU clock offset, you're not just adjusting the top end.
Right.
You're adjusting the bottom end.
Exactly.
So your base clock, if you set 100 megahertz offset, your base clock is going from 1006 to 1106. Right. And that is where you possibly get into stability issues, as with any normal overclocking, is that if you set the offset now too high, that the minimum is too high for some gamer application. It's trying to go above its power.
It's
and
possibly
that kind of
true.
stuff.
Now, what I've recommended is people use both sliders.
Yes.
Right. So use the power slider to give it more power, and then use the GPU frequency offset slider to boost the whole thing up.
That was my process. Was set the power basically to 130% all the way up.
Yep.
We're not afraid of that here.
No.
And then boost it to 100. Boost it to 125, 150, 175, run some tests.
What'd you see?
We got 175 to run most of the time. I think there was one instance where it crashed, so we kind of decided like 160, 165.
Yeah. I got to tell you,
pretty good.
These guys are, in general, massive overclockers. I think we can say that for fair, right? Because if you think about going from a base clock of about 1 gigahertz, and even a boost clock of about 1110, and being able to push that up to 1250, 1270, and run stable, I mean, that's what most people call just a massive overclocker.
Now, I know there are a lot of readers and people maybe watching this that when they hear this card is great for overclocking, what they're hearing is we left a lot of stuff on the table here. Like you don't design a chip to be overclockable, you design a product to be overclockable.
Right.
So you have this chip, it's capable of doing XX. You target a certain price, you target a certain power consumption, noise level that you want, you sell a product of that, and then you have an overclockable part, essentially.
Yeah, and the reason we pick this one is because the reason it's set where it is because it's 100%. All of our chips work the same way, and it's a beautiful experience. But for users that go off and buy these, they may be willing to have, maybe they got water cooling, or maybe they've got a better chassis, or maybe they've got a less. They're going to wear headphones all the time, so they don't mind if the fan blows a little higher.
Right.
So crank the thing up, right? And that is just so easy to do now, and I'll show you how to do it.
Okay.
All right, so this is what we're going to do. We're going to add the GPU offset. We're going to show you what happens. Yes?
No, go ahead.
All right. So the way I like to do this one is with a real game, which is Battlefield 3. And let me pull that bad boy up. So I got to go back to the screen.
Do you want to set your offset first?
Well, I want
to do a base first. Okay.
All right, and then once I get the base, we'll go and we'll set an offset.
Okay. So we're going to switch over here to our other
PC,
our other machine here, and our other screen rather.
Get rid of this guy.
Close 3D Mark and start Battlefield.
I hope I don't have to add that number again.
You're going to have to every time you start it. I don't understand.
Battlefield people, come on.
I don't understand it.
It's okay.
I lied. I apologize.
Well done, Battlefield.
My apologies to everybody involved.
That's awesome.
So yeah, I guess we'll see. While we wait for this to start up, I'm trying to think if there's anything else to mention. So 2 gigs frame buffer. Why 2 gigs instead of more gigs?
I think you'll see partner SKUs that have more memory, but the truth is that 2 gigs is kind of a sweet spot in terms of ROI on the frame buffer.
Okay.
We're hitting a total product cost, and we wanted to keep it below that $499 spot.
Right.
And as you add more memory, that's pretty expensive. It would drive cost up. And that's also something that our partners are really good at doing, just differentiating.
One of the questions we had on Twitter was to ask why you went to the stacked
Great
PCI
question.
or PCI Express.
Okay, I think we should. Can you see it?
Yeah.
Nice. So we should log that question as the best question so far.
Okay.
In case there's a need to know. That's the best question so far.
We might be keeping tabs of who has the best question.
Yeah.
Okay.
If there are really good questions, maybe we'll see if it really warrants it. But if there is a good question, maybe we'll kick you a card. All right. So back to this. Why is it?
Man, you're going to get that chat room going.
I know, chat room. Go chat room. Go chat room, go. So these 2 6s are here for a good reason, because if you think about it, the size of the fan is kind of limited by the board footprint.
So you can see the fan here as well.
Yeah, so the idea is we wanted more room for the fan, right? More room for the fan, and having the 2 6s stacked means that it's not right there, because if it wasn't stacked, it would be there, and that would either push the fan down or forward or smaller. So by having 2 6s that are stacked, we actually get footprint back on the board, and that allows us to have a bigger fan or to have a better positioned fan.
Okay.
Good question. You're the best question so far. Congratulations. All right, so I'm going to resume the campaign right where we were, and we're going to generate a base case, and I expect this to be around 1110 again, so we'll see what we get. Operation Swordbreaker.
You know how many times I've played this level?
I'll bet it's a bunch.
It's a lot.
I'll bet it's a bunch. All right, so back in here. I'm going to try to come up this way. And is our base, is it showing 1110 pretty much?
Let's take a look. Yeah, 1110. Okay. Pretty much flat.
Perfect. All right, so now I'm going to get out of here.
So when you have your own software and you're seeing that, you're seeing a flat line. You as a user, if you have a GTX 680, should recognize that I am actually clock constrained, not power constrained.
Correct. Right. So if you see a flat line, it means probably that you're not being throttled by power. You're being throttled by something else, and that something else could be anywhere from your chip really doesn't run faster.
Okay.
So at a particular temperature, at a particular utilization, we calculated that it would be unstable if we ran it faster. And if you don't like that, then you can of course start overclocking it. So gotcha. Let's go back to the chart over here, and I'm going to pause it. Okay, and just to pull it up so we can talk to it real quick.
You know what's sad is I'm trying to open up a document on my MacBook Pro here so I can record these questions and who asked them, and I have no idea
how to do it.
How to do it on a Mac, because I never use a Mac.
Nice. All right, so here's the log of that little run through we did, and you can see the clock was pretty much pegged at 1110, kind of a few little blippies there, and it went a little higher right there, and that's because the power is generally around 85–90%. So what I'm going to do is say, I think we can do better, and I'm going to pull up precision, and then I'm going to do a GPU clock offset. Okay, so I think I can safely do about 140 without breathing too hard. And then I'm just going to apply it, and I'm going to pull back up my chart, and then we're going to jump back to the game. Okay? And I need to unfreeze this thing first.
Yes.
Okay, and now we're back to the game.
Okay.
And the cool part is you'll notice that I still kept the game up, and the truth is you don't have to close the games anymore to do this overclocking. So if I return to the game, now our clock should be boosting higher, and we're still playing just a beautifully smooth game, only now it's running at about 140 megahertz higher by average. Okay, so I'm going to pause this, and I'm going to go take a look at that other thing. See how we did with the GPU offset. Okay, so let me switch this. Man, I'm getting better.
You're getting quicker at it.
I am.
The important part is I switched the live stream way quicker than we switched this back when to explain it.
Awesome.
So once that overhead goes away.
There we go. Good.
Okay, so there you go.
Pause.
So that's pretty cool.
So what you see here is now the clock is at 12:52, kind of gets throttled down to 12:28, 12:29, 1252, and that is really easy to do using the GPU offset. It's going to work. You know, these are really overclockable cards, and you know, you add the power, add the offset, and it should all just work. Now, one thing I could do, which I didn't remember to do, is I didn't lower the power budget. So maybe we could kind of like lower the power to about 110, and then pull the graph back up and get back in the game. Remember, we're at 1252. So let's see where we are now.
Why would you want to lower that?
If you didn't really want the card to get hot and to blow out heat, then you could lower the power budget back to say 110 stock, and you could still overclock. So now we're running with that same overclock, but with a lower power target. And what I would expect to have happen, if I don't die, is that the clock is going to be toggling or maybe even fixed at a lower number. So we're just doing a little bit of gameplay here, trying to kill all the bad guys, but I definitely don't want to get out of level. So I'm going to pause, and then I'm going to go out of the game and take a look at what precision says. So let's pull up precision.
Okay.
And I'll show you this again, HDMI 2. Oh, damn. There we go.
I don't know if you unpaused it.
Oh.
So now we got to run it again.
We don't have anything. Oh, bummer.
Well, let's unpause.
Unpause. We're still at 1250, but let's go ahead and run it. All right, switching games.
So you need to run it and not die again.
Yeah.
That's what you're saying. Okay.
All right, back in the game. Load the last checkpoint. All right, so now we're in, and we're shooting, blowing some stuff up.
And we're shooting.
And we're shooting, and we're not dead yet. Nice, and I'm waiting for those guys to pop up. And my brother, my fellow shooters are around. All right, well, I think we're going to call that enough. And now we're going to go take a look at precision. So what I did here from the other one, which was running at 1292, or was it 1282 something?
Yeah.
And let's take a look at what precision did this time. Okay. All right, that's kind of cool. So now with the clock actually, with the power lower, you can see what happened right away. I'm going to go ahead and pause it. But the clocks start drifting downwards, like 1228, 1221, 1220. This is where we were, 1252, and this is where we ended up just by lowering the power target. You get it?
Okay. So there are a lot of different variables at work.
A lot of different variables you can play in a lot of different way, right? And what users should do is kind of get in there and play with it and set and find the settings that they really like the best.
Now, one of the questions that's going to come up, it's already come up in the chat a couple of times, is does this vary from specific card to card? We have two different 680s here. Will it be different on this 680 than on that 680, and then a 680 that they might purchase? That's
a good question. The answer is yes. Now that we're taking advantage of all the headroom and monitoring hardware in real time, it means that different cards are going to perform differently. But the truth is that the variation that you see from card to card is relatively small. The variation that you see from game to game is relatively large. So again, most of the variation that we're taking advantage of is how the game plays. And that's the same for every card. But we are taking advantage of variation on the silicon and on the board as well. So some boards, you'll see higher max clocks than other, but that variation is relatively small. All right, so let's go back to the slides, and I'll show you one more thing. Actually, you know what, we'll skip the slides. I'll just show you the thing. I'm going to pull up an old game, and I want to show you two more features, and we'll probably get there. All right, so RIT Dribble. Does everybody remember RIT Dribble? This was done like
10
years ago already, right?
Yeah.
So this time I'm going to actually pull the monitor over the screen so we can just kind of do it in real time. Okay, so
once you bring the
yeah, there's that, and then I'll just double click on this to get the monitor, and that's down here, and I'll bring that up as well. All right. So what I'm showing you here.
Unpause here.
Unpause here. Okay. So what I'm showing you here is actually kind of interesting. If you guys can't see this, which I'm pretty sure you can't, the clock is actually running at 750 megahertz, which is below the base clock. But we're still running this app over here. So a lot of people are going to be like, what's going on? You said it wasn't going to go below 1006. Well, the truth is this game is generating 600 frames per second. And us raising the clock doesn't actually improve performance. But if the game were to suddenly spike, let's just make it bigger, and you can see the game got busier. Now we're automatically up to 1241 megahertz. It happens instantly, and you can see the power jumped up. And overall, GPU Boost is not just about raising the clock. GPU Boost also lowers the clock when we can. So if we can lower the power, lower the performance, and still get exactly the same frame rate, we'll do it. Let me show you another cool thing. If I go back to stock.
So let me clarify that. You said if you get the same frame rate.
Yes.
So you won't do that if the frame rate could go higher?
The way to think of it is we'll raise the clock if we think it's going to improve performance. We will not raise the clock if we think it's just going to burn more power and not actually deliver higher frame rates. So it's based on a lot of internal monitoring. It's based on what the board's doing, what the frame buffer's doing, what our internal GPU is doing. It's all kind of trying to predict whether higher clocks is going to have a better effect. Now, I know that makes some people nervous, so we did add a flag in the control panel. I'll show you that. If you pull up the NVIDIA control panel, and then you go to, let's see, Manage 3D Settings, and then under Manage 3D Settings, there's a Power Management mode, and default is Adaptive. You guys probably can't see that.
There you go, a little bit better for
okay. But if you click on Adaptive, there's a Prefer Maximum Performance, and if you click on that, we won't lower the clocks.
Okay.
Okay. So if you want
if there's a specific use case, you like to run that particular demo, DirectX demo, at 1,000 frames instead of 800 for whatever particular reason, you can disable that feature.
Yeah, but even more clear, we would not expect changing that feature would increase performance, right? Because we wouldn't lower clocks unless we expected, right? But it might be some small numbers, but it's going to be relatively small. So let's take another look at what's going on. I'm going to set this back to stock, okay, and apply it. And again, now things should have changed in real time. The clock is now at 719. So what I'm going to do is actually make the load a little bit smaller.
This is one of those apps where you just shrink the window.
And the load
this is like the best application you can use for demos ever.
That's right.
Because you just make the window smaller and
the load
things happen. Yeah.
Now we're down to 27% and the clock's
37.
We're
37
at 37%
here.
And we're at 500 on the clock. So now it's basically at 35% and still 500 megahertz. So what that means is the clocks are getting really, really slow. If I make it even a little smaller, that might be enough. Now we're down to
28%.
And we're still at 500, but I think the clock will probably come down a little bit more. We'll see.
Huh.
Maybe not. Well, that's still pretty good. We're able to get down to roughly, well, that's not moving.
I think that's why the clock's not changing.
I think that might be toast. Yeah. All right, let me try it one more time.
Try one more time. What do you call this again?
I don't know what the real name is.
Rit Dribble?
I call it Rit Dribble. I don't know if that's the right name. I'm sure whoever made it.
I think you said that at the editor's day too, and I was like, I don't know what he's talking about.
Where did he see from?
I don't know what Rit Dribble is.
So watch the clocks. We're coming down. We're just stepping down automatically because the load that this app is putting on it is relatively moderate. We're down to 42% of power. But if I shrink this thing, I did it again. If I shrink it too much, it just dies.
It doesn't like to be shrunk, is that what you're telling me?
It doesn't like to shrink that much. Let me try one more.
That's fair.
Yeah.
So what are you trying to demonstrate there, though?
Well,
is that
basically I'm just going to say that loads, when they get smaller, will allow us to drop the clocks very quickly. But it's not the only way that we have to adjust performance. So let me show you that one. Instead of the automatic clock dropping based on our internal measurements, we also added a new thing called a frame rate target. So in Precision, there's this little guy here called frame rate target. And if you click on it, you can enable it and set the number of frames that you want to get. So I'm going to just set it to like 48 and then apply it. Now this, after you set it, you have to restart your app. So I'm going to restart this one more time. And now instead of 600, what we're actually generating is 48 frames per second. Okay, that's pretty cool.
Yeah, you can see you can actually see both in the OSD and the actual overlay in the application itself. You're running right about 47, 48 frames per second. It's pretty accurate there.
Yeah, so right here is the frames down at the bottom, and I think that says 48.
Yeah.
Okay, and if you look at the power, we're down to 29% power, and the clocks are at 550. Now, if I, again, shrink this load a little bit, what you'll see is we're down to 26%, running 550, and we're at about 4% utilization. But if the load peaks up, you know, guess what? Now the utilization went a little bit higher, but the clock stayed low, and the power is still really low, and we're still getting, you know, that 50 frames per second or whatever. So this technology is a really new groundbreaker, right? I mean, we haven't done frame rate targeting before, and it really makes gameplay much more reasonable. I don't know if you had a chance to test it.
So I did, and actually, if we switch over to input 4, I can show a little bit in our review at PCPro.com. We did test frame rate targeting specifically, and the use case that I like for this is that if you are a gamer that likes to play Battlefield 3, you want the most performance you can get out of it.
Right.
If you like to play Counter-Strike still, or Left 4 Dead 2, you don't need to run at 200 frames per second. Right, so by going into the EVGA Precision software, and we should point out, EVGA is not the only company that's going to have software with these features.
ASUS, I mean, every AIC, every card manufacturer has their own tools. So ASUS, MSI, Gigabyte, PNY, everybody else.
Okay.
And those tools are all designed with their UIs. And
so MSI Afterburner, they'll all have it. So if we look here, if you look at the on the review specifically, you'll see that I decided to set the frame lock to 80, and I chose to use Deus Ex. Even the new Deus Ex, it runs really fast, and you know, it's like, okay, if you're over 80 frames per second, maybe it's not useful. It's not useful for anything. You don't want to limit it for anything, and so you can see here in this graph, what you're seeing is the blue line is frame limiting disabled, and the red line is enabled, and you can see the red line straight across with just a couple of tiny little hiccups in the 79 point something. We're right at 80 frames, and you can see without that we would be spiking up in the 160 range, which is good, but maybe not super useful. And you can see what this does to our averages. Our average drops from 135 to 79.9.
Wow! But
that's what you want if you're setting this level. And what I think is maybe
did you measure power? More
telling is so we kind of show that down here in the power consumption.
Wow!
We're running at with the feature turned off, you get 321 watts of power consumption. With the feature turned on, you're getting about 276. So you're actually saving 45 watts of
45
power.
Watts off of your entire PC power, right?
Total PC power, by limiting that frame rate to 80 when you feel like that's useful. Right?
That's pretty cool.
And to me, I think that's pretty cool because as a gamer, I still do play Left 4 Dead 2 and all those types of games. So I find it beneficial. There's no real purpose in running at 300 frames per second anyway.
Right.
And I think it's one of the other interesting features being brought to bear with the 680. Is that something that we'll see in other families?
I mean, this is such a cool feature. We're definitely going to be taking it to iCafe, very likely the mobile space. And you'll probably see it as a GTX feature for going forward. Because you know, our users love it. It has a great use case. It gives you a better gaming experience, and it kind of is a no-brainer.
Are there any of these features that will find their way back to users who may have current 500 series cards?
You will see a bunch of the new technologies I'm going to talk about on older cards. So, of course, you won't see GPU boost because that requires hardware changes on the board and a lot of software. But you will see a technology called adaptive VSync that we're going to talk about in just a little bit. FXAA in the NVIDIA control panel, that'll be available on older cards as well.
Okay. Sounds good. So what do you, adaptive VSync? Do we have any slides on that, or you want to just go through it here?
Let's just do yours, they're fine.
So adaptive VSync is, everybody knows, if you're watching this, you know what VSync is. I'm going to assume that.
Hopefully.
So VSync eliminates tearing in games, but it caps your frame rate at 60. Fine, whatever. Or 120 if you happen to have a 3D vision capable panel, right? So the issue has been that it has to run at a multiple of 60 or 120 in order to run correctly.
Or a divider of it.
Yes. That's what I meant. So if your frame rate would dip from 60 to 58, let's say, it would actually have to go all the way down to 30.
Correct.
In order for it to maintain no tearing on the screen.
Right.
And what happens is when you would see that, you'd see these kind of little stutters, these little glitches in the game. Now, we were going to try to demo this and show it to you guys on the stream. The problem is, over streaming video that is not running at the same frame rate as the game, these kind of stutters, these are very difficult to detect and to see in real time anyway. So we're trying to demonstrate it a little bit through here and just by describing it. Yeah, death by slides, so to speak. So here is what you would normally see, right? If you have VSync enabled, when your frame rate went below 60, it would have to go all the way down to 30, and would have to wait until it went above 60 to go all the way back. Now, if you have VSync turned off, which I think a lot of maybe high-performance gamers tend to do, The issue is when you go above 60, you see tearing, and tearing is this. Tearing is where vertical lines don't match up. It doesn't have to be necessarily vertical, but lines don't match up because what you're seeing is 1, 2, 3, 4 frames being rendered in this little window of a game, and so you're seeing
on one refresh of the monitor, you're getting portions of 4 frames.
And this is actually really important for gaming in a lot of ways that we're not going to talk about tonight, or I don't know what time of day it is, this morning, today, whatever it is. But this is really useful information to have, but it doesn't produce the best kind of gaming experience. So adaptive VSync is something that you guys introduced. Is this something that will come backwards?
Yes.
Okay. So this is a software thing that basically it enables VSync whenever your computer is running over 60 frames per second. Whenever the game, which is when you want it there, right? Because then you would have tearing otherwise. But as soon as you dip below 60 frames per second, you'll notice this kind of nice curve as opposed to the harsh
jump down to 30 or 20, yeah.
Down. So you'll see that your frame rate will kind of gently go into the 50s and back up, gently go down into 30s and 40s and back up, that type of thing. And it reduces the stuttering while making sure you still don't have tearing in the game.
Right. Now the truth is, just to be clear, Ryan, if you go back there, there's a possibility, because now we're letting frames be displayed whenever they're done, except if there's a high frame rate. So that means as you start coming lower, you might see a tear in a frame, right? That's the trade-off. Is can I see a tear when frame rates are starting to drop versus stutter? Because it's a trade-off that you just can't get around today. Because you either have to synchronize to the monitor, or you have to let the frame go as soon as it's done. And it turns out, though, on the positive side, when frame rates dip below 60, you tear very little, right? Because there's never a time when you're displaying more than 2 frames per update.
Gotcha. So what we did in our testing here is we actually ran Metro 2033. This was a game that averaged with VSync turned off, which is when we normally do our testing. Again, it's pretty hard to see on this. The blue line goes above 60, and you see, it's smooth all the way, but you get tearing above 60. The red line, you'll notice, you should go to the review and make sure you see it. You'll see these, it hovers around 30, it'll spike up to 60 and back down. Now, keep in mind, Fraps is recording this, it's only recording once a second. So you're seeing multiples of these in the same second.
A lot of averaging.
Yeah, but you'll see that it's very much dipping all the way down to 30. When we look at the green line, which is actually us enabling the adaptive VSync feature on the GTX 680, it doesn't go above 60, which is what we want, but it also kind of very smoothly follows with the blue line when we dip below
That's very cool.
60. So it's a good demonstration of the feature. And I played Metro on it. I played several other games, and it works out really
You like the experience you got?
Yeah, it actually works really well.
Could you tell the difference between the stuttering experience and the smooth experience?
You could, yeah, you definitely could, especially like in Metro 2033 because of how often it was kind of crossing this 60 frame mark. It was a perfect use case for it. You should have used that.
I should have used that. Drew, I'm sorry.
It's a perfect case because you see a lot of that movement up and down.
Why didn't you tell me about this?
Well, because I didn't have the card yet. That was the issue. And as a side benefit, it actually look at your average frame rate is quite a bit better with adaptive VSync than with VSync on anyway, because you are in general running higher than 30 when it's when regular VSync.
By the way, this is not fake, right? In the sense that this does truly represent a quicker response time. Right?
Yes.
So when you're doing this 42, what's actually happening is your response time is longer as well. You get more lag. That stutter is real. Whereas in this case, you don't get as much lag, and you do get relatively higher performance.
Yeah, so that was pretty cool. It was I would consider that adaptive VSync and frame rate limiting to be on the surface very minor features for this particular launch. They turned out to be
really cool.
Yeah, really cool. Like really good additions for a gamer buying a new card. Besides just better performance, which is there, but it's little extras.
Yeah, I mean that's what I love about 680. We've done more than just push it up to the next notch. We're spending more and more time on the gamer experience, and you'll see actually more features like this from NVIDIA in the future. It's definitely a major focus for us now is delivering. I mean our goal is to deliver a perfect experience. Right, perfect means that you run a game and you get a silky smooth, movie-like experience no matter what's going on.
Right.
That's where we're heading.
Well, I hope we get there soon. Do we have any other demos specifically to get to?
Let's see. We did frame rate.
We can't really do any of the surround demos.
Surround demo.
I was thinking about setting up. I would have had to have two systems, but to demo the triple display stuff over there.
Yeah.
I was hoping before I left my house to come over here to do this event was that we would I would have gotten the second 680 in from Galaxy.
Oh, they're sending you 680?
Right? So we could go through. Here's a retail board. Maybe plug it in and do some SLI testing. That kind of stuff.
You'd like to do that live?
Of course.
Wow. I don't know.
Hey, look, we've got a second GTX 680 right there.
Gee, look at this. No, I don't know, man. I don't know.
We'll see.
We could.
It's interesting.
That is interesting. Maybe after we're off camera.
Okay. All right. You don't want to do live, brand new testing?
I would love to. And that's the yes. I would love to, but it's gone so well. Oh, let me show one thing. I want to show the adaptive VSync control panel thing.
Okay.
I had it. Damn. And do we have any other good questions?
There's been quite a few questions talking about like CUDA performance, Adobe Photoshop CS 5.5. Will this GPU run faster than the 580 did with those applications? And I know that was something that was never really touched on with the media yet, has been kind of the compute performance
yeah, and the truth is I can't really talk about the compute performance either right now. We're going to have a lot more to say about compute at our compute conference, which is called GTC.
Okay.
So stay tuned. This does have a very good compute story, but on the consumer side, it's not as strong as it will be on the professional side.
Okay.
So let's defer that one. And I want to come back to the control panel. So here I am going to launch the NVIDIA control panel.
Let's move it to the other screen where we have a little bit better view of it. There we go. Yeah.
Okay. And I'm going to come down to VSync. And so right now there's a new entry called VSync, and it says use application or on or off. Those are force on and force off. And then there's this new one called adaptive. So if you want to do adaptive VSync, you just pick adaptive. This last one is adaptive VSync refresh over 2, which is a horrible name, I know. But it works just like adaptive, which is sort of centered around the refresh rate, but only it does it at half the refresh rate. And the reason you may want this is because if your game is sort of oscillating between 40 and 20 frames per second, if you turn this on, I guarantee you, you're going to prefer the experience you get, because what it'll do, sort of lock you to 30 frames per second and give you a smoother experience, as the game will sort of be able to lock into that rate. Everything will run just much better. Okay, so that's adaptive adaptive VSync and adaptive VSync over 2. Cool.
So that's pretty much what has changed in there in the software side of things. I know you've had some improvements on the surround side. Now you can enable maximizing in just one screen. You can do centering of your taskbar as opposed to having it span across the whole thing, which is great.
Absolutely. The way to think about the new software features on surround is that it gives you the extended desktop experience when surround is enabled. So things like maximizing windows, putting the taskbar in the center, picking on where the windows go, all of that works with the new software features of surround.
Cool. Well, I think that's all we've got in terms of specific features to talk about. So let's go through some of the questions that have been cropping up.
Great, let's do it. Can I grab some water real quick?
Yeah, let's do that. So for some reason when you turn off the wireless mics, instead of sending no signal,
it sends static.
It sends everything.
Nice. So it's like a white noise blasting everybody's ears.
Yeah.
Sorry, guys. Sorry.
So one question that came up in the chat was if you run SLI, are you still limited to 3 monitors in terms of surround gaming?
You are. Okay. So surround gaming is still up to 3 panels. It's really only 3 panels. And now we didn't mention it, but we do support a 4th panel.
Right.
But that 4th panel can't be part of the normal gaming surface. We call that an auxiliary display, and you can use that for things like chat or email or movies or whatever you want. But the 3 panels will be your sort of gaming surface.
Somebody said we woke up their neighbors with our static.
Nice. So, sorry about that. Sorry.
Yeah, that was my fault. I totally forgot to tell you that. Is 2 gigabytes enough for three panel gaming?
Absolutely. We see, and I think the data that you showed that 3 panel gaming works really, really well with a single GTX 680. So I'm pretty excited about it. I think SLI, you'll see really good scaling for 3 panel with SLI. And but even going further, as games get bigger, we'll probably be talking about bigger frame buffers over time.
Okay. Will add-on board vendors be able to increase GPU boost headroom power from factory as OC cards? How is the aftermarket overclocked retail card going to change now?
That is a really good question. I almost want to go back to the slides for this. I don't know.
Sure.
Okay, so we'll go back and let me show you a slide that makes this more clear. Okay, so I think I need to change this guy to that guy. Okay, and then I'm going to pick, let's see.
So let's go here. All right, there we are.
Go to slide number 11. Okay, so this was how AIBs used to do overclocking, right? They would, some had like their super overclock, which what they would basically do is raise the clock and raise the voltage, and that had to work for all games, right? That was the normal way to overclock. And then they did the uber super overclock, and they would bin it, right? So you would see 3 different SKUs. There'd be the stock SKU, then an entry-level OC SKU, and maybe a couple as they raised, the tightness of their bin that they did. And they would all quote this one clock as the new overclock, right? So instead of maybe being 754, this might be 800, and that might be 850. Well, with GPU Boost, what they're going to do is have, just like a user can have a GPU clock offset, AICs can put a GPU clock offset into their VBIAS. So they can actually shift this entire curve in their VBIAS. Now, that does 2 things. It changes the operating mode, but it also changes the base and the boost clock. So if you think about it, the new specs from the AIB will be reflected by the new curve, and they guarantee all of it. So it's almost like user overclocking used to be, where you could buy a card and you maybe be able to clock it or not, and it was best effort. But if you bought a super clock card, then it was guaranteed at a higher clock. Same thing with GPU Boost. If they add a base GPU clock offset, then they're going to advertise a new base clock and a new boost clock that's higher than
So they'll be marketed
with a higher base.
With 2 clocks,
yes. So there'll be 2 clocks. They'll be both higher. And the way to think about it is they're both going to be moving up by the same percentage.
Okay. So you won't see that variance between the base and the boost increase.
Right, because that just gets too confusing. We didn't want a million different variants of overclock cards where you could not tell which one was better than the other one. So by having a simple rule where in the beginning we're going to try to encourage AIBs to increase the clocks by the same percentage.
Right.
That means you'll be able to compare them across AIBs based on clock.
Okay. The EVGA control panel, will it work with other vendors' cards immediately if that software isn't available from, say, MSI, those guys?
Yeah, so that's totally up to EVGA to decide. I believe the answer is yes, but I will take that as just my understanding. Really need to talk to those guys.
Okay. Is there any capability to set hotkeys for those settings? I'm guessing that is software specific. That's like a software feature, not necessarily an NVIDIA feature.
It is totally a software feature. In EVGAs, they do have these things called profiles, and you can have collections of settings and use hotkeys to get there.
Okay. Now, when I do this, all the information that they're getting here now that is new, the offsets, the power targets, that is now part of a new API from NVIDIA?
Correct. We have a new version of NVAPI. So NVAPI is the way our driver communicates to all these third-party software packages. So folks like Riva Tuner or GPU-Z or all of the third-party, sort of enthusiast tools like Precision, all access all of this GPU information through NVAPI. And it is on our website. It is public. And really, we'd love to see anybody grab the API and do cool tools. Right? That's what I'd like to see. What I really want to see is these settings per game. Right? So I really would I'd like this to become a game profile. And if you really think about it, that's what you want, especially with frame rate targeting. You want that to be different per game based on the experience that you're going to get.
Yeah, I would agree there. One of the things, I don't know if we mentioned this earlier, that the power consumption that we saw would be typically when we test video cards, we look for power consumption. We pick a game that draws the most power. In our case, we're using Battlefield 3. Are we using Battlefield 3? No, maybe Metro 2033 or something like that.
Maybe Metro, who knows?
Yeah. So, but with AMD cards and NVIDIA cards before the 680, you would see variance. And now I'm thinking it's possible, or at least it should be, with GPU Boost working the way that it's supposed to work, that the variance in that peak power consumption would be very small.
Yeah, it would be smaller than it was.
Okay.
Right now, you're not always going to be consuming 100% of the power available because you're limited by who knows what. You could be GPU limited, you could be CPU limited, you could be disk limited. So adding GPU power does not always mean that you're going to consume more power, right? It's more of a target, but you will see the variation tighten up, right?
Okay. Yeah. So it won't go away completely.
Right.
It's not a perfect technology where it's able to maximize that.
Exactly.
Okay.
And sometimes apps are such low usage, they're so light effectively, that you hit the clock frequency limit before you hit the power limit, right? And if that's the case, the app will take less power than peak.
Gotcha. Here's one from Gabriel, who asks, will the idle clocks in the GTX 680 still be limited to the same as 3D clocks when multiple monitors are connected?
That is an awesome question. That goes on the list as a tough, maybe 2 right now, Gabe. It might be question number 2. But the answer is no. That was a bug that we fixed. So on GTX 680 with multiple monitors, we go down to our lowest idle clock, even with multiple monitors connected.
Okay. We've got a lot more. Let's see. Do you need to use a display port for 3-screen gaming setup like the AMD cards?
You do not. As a matter of fact, you can use 2 dual-link DVIs and 1 HDMI to get 3-panel gaming. So
that is something, like I said, it's not even in our review. When we get done here, I'm going to go up and update it. That I think is under-advertised.
We did not do
from the new product. Is that with AMD cards, you could do 2 passive, 2 DVI connections, but you had to have an active adapter. Now, active adapters are much more common now, and they're a lot less expensive than they were when AMD's Infinity first came out.
Right.
Like that active one that we were using earlier was like $130.
Right.
They're not quite that way now, but the simplification of being able to use DVI, and HDMI, and not have to have a DisplayPort monitor.
That's pretty cool.
I really do like that.
And I'm delighted because we have 3 TMDS, which is the block that drives HDMI and DVI. We have 3 of those guys, so you can drive 3 of them independently.
Does VSync still work with 3-screen gaming? That comes from Ashley Laywood.
You know what, Ashley, you have stumped me. I think the answer is yes, but I don't want to say the answer is yes. So I will check on that. Do you know?
I do not know. We can hook that system back up to the 3 panels and see.
Well,
usually I would say, well, I guess it's harder for me to know for sure because most of the time our games are not running well above 60 frames per second when we're running 5760 by 1080, and that would be where you would see the tearing.
Yeah.
The further above that you are, the more tearing you're going to see, and in general, we are below that.
Right.
So
you haven't seen a lot of it, but I
haven't seen a lot of it.
I think I'm going to go with I think so, which is for me generally yes, but I'm not sure.
Here's one. Alexander is asking about going in depth with the reference cooling system. Has anything kind of changed with that?
Yes, a lot has changed. I'll tell you what, I would probably say I would rip that apart, but instead, let's.
I got a screwdriver.
Let's put the slide. Do you have the slide there? Or?
I have. We can do the slides there. Okay. I have pictures of the one taken apart here, but
yeah, let's just show a slide.
But if we've got slides of it, that'll be more. That'll be cleaner.
Shoot. Okay. And I believe it's over on the other screen. So let me switch this back now using our advanced screen switching technology.
The remote control.
All right. There's our card. There, we're kicking butt. Still kicking butt.
You wouldn't show slides if you weren't kicking butt.
I know. We would show different slides. Oh, boy. I hope I didn't take it out.
We may have.
I think we did.
So switch to this.
Okay.
Switch to my laptop here, and
you can show the slide.
Yes.
Okay. That's
here we go.
That's the basic.
There we go. So that is the overall card. There's the back. There's our stacked power. There's the fan. Yeah. Where's our?
I want to see the thermal. There we go. Perfect. Hey, you're great. So what's new is this has an embedded heat pipe in it, and a very high efficient embedded heat pipe. And then you'll see that the fins.
I actually got a better view of those fins right here.
Oh, there you go. Perfect. So the fins are actually angled, which is the first time anybody's ever seen that, right? So it's a cut back fin stack, and what that actually does is deflects the air at an angle. And it's doing that because if you look at our back bracket, like looking right here, the fins sort of direct the air out the bracket, so it doesn't just kind of bang into the connectors. It flows out in the correct way.
Okay.
So actually, if you put your hand back here and feel it, the air is actually blowing at a slight angle.
That's one of the things I was going to ask is because we have less than one full slot of exhaust.
Right.
is there any cooling issue with that? You know, it's because a lot of them, you know, cards traditionally doing this and have the full, full
well, I would
slot
say
exhaust.
if we were venting 250 watts, then maybe it would be a lot more difficult problem. But because we're venting less power, we can afford to run the fan at a reasonable rate and still, you know, cool it with just that available fin stack.
One of the things I liked, I don't know if I included a picture of it, but there's just, I don't think it. Oh, there's a good one of the
it's
die.
a small die.
GK104A2. I don't have a picture of it, but the cord, the power cable that goes to the fan is actually has a little plastic tab over it that screws down to make sure that the cable doesn't get in the way of the fan. It's just little things that look like they're thoughtful. Thought out well.
I would say that
I was also pleasantly surprised to see that the I was worried about the stack. There was going to be some kind of bare wire
you couldn't get in there.
Sticking out, and I was going to electrocute myself or something if you had the cage off, but not the case.
Very unlikely.
It's unfortunate.
Very unlikely. No, I think actually, again, the engineering team, in this case our board solutions team, has done a fantastic job. The card looks great, performs great, and I even like the ID. You know, I like the new text that we put on there, and I like the side of it. So those guys did a great job. Beautiful.
Yeah, it's nice. I think it's a good product overall. Let's see if we've got any more good and or interesting questions. Let's see. What has been added or removed in the new GTX 680 that it needs a 550 watt power supply when the 580 required a 700 watt?
Oh, what's been removed?
Yeah, we're just talking about the efficiency at this point.
Well, I mean, back to why is the power so low? Why is it 195 versus 250? It goes to the fact that the design is a lot more power efficient. So the chip is more power efficient, and we're in new technology. We're in 28 nanometer technology. So a combination of the technology and the chip improvements means that to get the same performance, we can consume much less power. So I think that's the easiest way to think about it.
Why did they choose, this is from Freedom Music Group.
Freedom Music Group.
Why did they choose the name Kepler out of any other famous person? Was he a big influence on somebody's life at NVIDIA?
That's funny. Well, in case, I'm about to give it away, in case you have not realized, all of our high-end GPUs are named after famous scientists. So these are not random names, so Fermi, Kepler, and there's the next one, and you know the other one.
I've always been a big fan of the Tegra line that has the superhero code names. I like those.
You know what? I actually think that I'm delighted with the sort of the scientist line for the high end, and superheroes for Tegra sounds actually pretty cool too.
Yeah.
So
let's see. CPU. No. We got a comment from Gabriel. It says outstanding. Thank you very much.
Oh, thanks, Gabe.
Let's see. Let's check the live. If you've got any last minute questions before we get in here, let's go to the chat. We'll see if anything.
Thomas Peterson, I love you. Wow.
They use your full name too. Wow, nice.
You know what? If that's Tracy, I love you too.
Let's see. Is there some Tegra DNA in this? I don't think that is an issue. How long until non-reference 680s are available?
Very soon. Very soon. So our partners are, going as fast as they possibly can. Everybody's excited about the chip, and I've already seen a couple of new partner SKUs that are going to be awesome. As I mentioned, the chips are just massively overclockable, so I think you're going to see lots of partners taking advantage of it.
Now I want to do let's do maybe a quick stock check. We already saw Newegg might be sold out. Maybe they're getting some more in.
Yeah.
That kind of stuff. Check around.
I would say
keep looking.
We found that Tiger had some, right?
Yes, Tiger Direct had some, and check Micro Center. They're local here, local-ish.
Yep, they are available worldwide. So if you happen to be watching this live stream, can they watch the live stream from Europe?
Anywhere, yeah, absolutely.
So
anywhere.
they're actually in all major countries, all major areas that buy our GPUs are in stock, or were in stock this morning.
Right.
But we're hearing that they're kind of flying out of shelves. So
somebody in the chat says Newegg has the EVGA1 in stock right now.
Nice.
Now somebody's asking about the mobile side of Kepler.
Yes.
Now that was also covered at the Editor's Day. It's not something I did. Actually, the original plan was to have our mobile guy Matt Smith call in through Skype.
Oh, okay.
Didn't have time to configure all that with all the other stuff going on last minute.
We were a little busy.
I didn't want to throw that into the mix.
I think you made the right call.
Yeah. So they were asking when the mobile version of Kepler was going to be out.
Wow, that's a great question. And I can't answer that question because I don't want to comment on any unreleased products. But we think that we've gained share on the Ivy Bridge cycle. So we're delighted with our offering for Ivy Bridge. It's done very, very well. And that's all I want to say on that.
Now there is one Sandy Bridge Kepler machine already for sale.
Yes.
That's the one we used for our review. I know it's for sale in Asia, and it is going to come to the U.S. sometime soon. It's the Acer Aspire Timeline M3.
Yep. Did you get a sample of that?
Matt has one.
Okay.
It is the GT640M. I was actually thinking about having him send it in so we could
play with it here.
Yeah, show Battlefield 3 and that kind of stuff running on a mobile system, but we didn't have time to work that out either. Maybe another day.
Maybe another day.
When we get some Ivy Bridge systems.
Yeah, but I got to tell you that Kepler, you know, we talked a lot about power efficiency or perf per watt. If you think about that, that fits really, really, really well for notebooks. So perf per watt is not just good for desktop, it's really, really good for notebooks. And ultrabooks.
Yes. Which is the interesting thing, right? That you can put a discrete GPU in there with Optimus and be able to still get good battery life and that kind of stuff.
It's awesome technology.
I don't want to talk too much about that because that's not what I focused on for the last week.
And it's not what
I was on this. Right. Right. So we're both outside of our realms there a little bit. Somebody wants to know why it was named GK104 if this is going to be your high-end part.
Wow. Well, I would say that all those names, all the GK names, come from engineering. And engineering basically slices up numbers to be most effective for internal management. And I would not read too much into the code name for product positioning or where it's even going to sell in the market. So they're totally unrelated. And the truth is, I kind of wish that we didn't call our chips, you know, those numbers.
That's the useful nomenclature for us and in the outside world for the enthusiast crowds and for editors and me and that kind of stuff. Do we have? They were asking about. Did we show the fur demo? Did we show the?
We didn't show.
You want to show those?
We could.
Real quick?
They're pretty cool. Those are pretty cool. Maybe we should.
Okay, let's switch. Let's switch back to the I think PC or HDMI 2. I think it's HDMI 2.
PC is the main screen. Yeah, this is good. So we'll just do it right here. So the first one I'm going to show is fur. Now, what is fur showing us? Let's just describe it a little bit. Fur is actually a hard problem. I mean, getting hair to look good is like impossible.
Just ask me or Tom.
Just ask me. Yeah, I mean, I've noticed that this hair doesn't look good. Kelly has nice hair. But what you're seeing here is effectively 100,000 hairs being simulated in real time. And the way this is working is each of these hairs kind of bounces off to the hair next to it. They all deflect the air, they deflect each other, and it starts to give you that really, you know, truly hairy looking experience. So we can kind of animate the guy, see what he looks like, spin it around a little bit, and really, excuse me, the point of this demo is to say that NVIDIA on our developer technology and our content tech group constantly works to develop these little demos. And we make them available to third parties in the form of an SDK that they can integrate into their games so that when you and I are playing games, maybe next year, you'll see, you know, suddenly instead of this flat kind of texture, goofy looking fake hair, you'll start seeing really believable hair. It's just an example of one of the things that NVIDIA invests in, which is making gaming better. Okay, and this guy, you can play with a few things. You can change the wind. You can change how fluffy the guy is. So if you don't want to be super fluffy, you can make him a little less fluffy.
A little less fluffy.
A little less fluffy, maybe really fluffy. You know, it's just hard to let it go once you start playing with it. But that's fur. Right? Now,
that's fur. All right.
That's fur. And what it is a technology demonstration.
Somebody in the chat room says, "I wish my hair was that thick."
Nice. Yeah. I wish my hair was that thick. Yeah. I think we both do. All right. So let's do fracture. Now, fracture is shockingly cool. And what it does, let me pull it up here, fracture.
Somebody wanted to know, was that fur done by CUDA or was it?
Physics.
Physics.
Apex. Yeah, so it's basically a demonstration of physics.
Okay.
Okay, so now what we're looking at here is another demonstration of physics. And in this demo, what I'm showing you is 3 columns. Now, one of the problems with games is that things always break the same way, and it's really boring, right? If I say break this column, you know, it kind of, maybe I can't break this column. Let's see.
Space.
There we go, with a ball. Okay, that breaks basically one way in most games. Like if you're shooting something, I'm going to shoot it with a laser now, right? That basically would be the same way for everything. But what we've done now is made that become GPU accelerated. So every time it breaks differently. And all of the broken bits interact with each other. And as a matter of fact, you can keep breaking them. So I'm going to take that block and break it over there, maybe take this block and slam it into that. What's really cool is this is being simulated in real time. The fracture doesn't need an artist to figure out how to fracture it. It's actually being calculated on the GPU. And again, this is just another example of physics and how physics can make games better. So
How far are we from seeing this actually integrated in games?
I would say you should see games like this probably in about a year would be my guess, right? And what it is it's just you have to adopt the new, UI, adopt the new method. It's pretty cool, huh?
Yeah.
It's fun, actually. I was with a friend yesterday and played with this for a couple hours, believe it or not. It does all kinds of things. I don't know exactly why we were playing for so long, but it was a lot of fun. And you can take these guys and smash them into each other if you want. So basically, just kind of grab it, pull it up, smash it down.
Now, somebody asked in the chat room what the specs of the systems we are running on, and I guess this is our standard PC Perspective GPU test bed. So it is a Sandy Bridge E Core i7-3960X processor, 12 gigs of memory, no, 16 gigs of memory.
Nice.
And it's running off of a Western Digital 600 gig Velociraptor and that kind of stuff. It is being cooled by the Main Gear Epic 180 cooler, which is actually really nice, which allows us to do it really quietly so that we can do accurate noise level testing.
Did you take this out of one of their systems?
No, they sent it to me.
Oh.
Yeah, it was very nice.
Wallace and Chris?
We appreciate it. Yes, thanks to both of them for that. And then obviously the 680, but the driver revision for this, so we test on is 300.99. I assume that driver version is available today.
Oh, yeah. There's a launch driver
consumers.
out there.
Okay. All right, that's good. And then, that's the specs. We're powered by, what is Corsair AX 1200 watt power supply as well.
It's more than we need right now.
Way more than we need, but we build a test bed, so if we put in 3 of these soon,
be good to go. Soon you will.
So if I just keep yours,
just keep mine,
wait for the Galaxy one to show up.
Yeah. When do they say you get your Galaxy?
It's supposed to be here today. Nice. I'm sure it's at my house right now. The problem is we had it delivered to the house instead of the office.
Wow.
It's a little bit different. We're still new to the office space.
It's beautiful, actually.
Thank you. We're still new here. Still do a lot of work to do.
You need an office dog or an office cat.
We have an office dog, but I didn't bring her today, so she wouldn't distract us while we were trying to do this.
That would be difficult.
Somebody says there are 155 people currently chatting in this channel, and they would all like a free card.
Wow. That is a very noble goal. It's a noble goal.
I think they would rather sell those to you.
Yeah, I think we would. But seriously, check out Newegg. Check out Amazon. Check out Tiger. Hopefully there are cards available out there somewhere.
I was just going to do one last check at Newegg and see. There is an EVGA GTX 680 in stock for $499 at Newegg. Actually, awesome. But there are a lot of other ones out of stock. MSI, Zotac, Galaxy. So EVGA has them in stock. So if you want to go do that, go ahead.
That's awesome.
Chances are EVGA had their stock input much later in the day than everybody else.
And I don't know how they're doing. They may be trickling it in too, so that
way they stay in stock for a little bit. So one of the worries that a consumer has is when a new product comes out, maybe they're excited to buy it. Is this?
That they just
is the auto notify button, right?
Yeah.
So how do you guys try to make that so that's not the case? How do you fix that?
The truth is that there's always going to be a ramp on product, but what we normally do is we wait for a certain period of time to make sure that there's sufficient volume in the channel before we launch. That's what we call a hard launch. So hard launch is timed to, cards have been distributed worldwide and that they can actually be bought at e-tail and retail. And we do that. We basically try to make sure there are enough in volume at e-tail and retail to service the people that really want it that day. But it's a tough nut because if we go too early, then we don't start sales and it basically penalizes the cards that got there early. If you go too late, you're just wasting money because cards are sitting in inventory. So we try to balance it such that cards are available to buy for people that want to buy them on the day we launch worldwide.
We had one question. Actually this is from Josh.
Oh, Josh. Hey, Josh. I hope it's a good question.
It was just wondering if it was a heat. Is it a heat pipe vapor chamber thing, or is it just a combined heat pipe?
It is a combined heat pipe. So it's not a vapor chamber. It's an embedded heat pipe.
Okay. I guess that's it. Let me check Twitter one more time. We're kind of rounding down here, see if there's anything that stands out. Several people ask about performance increases from PCIe 3 versus PCIe 2. Is that something we'll see mostly in SLI configurations versus single GPU configurations?
Really varies by game. So if you see games that are not fitting in the frame buffer, they tend to have more PCI Express traffic. But honestly, our driver team has tried hard to balance workload so that it remains in the frame buffer. But there are games where it's CPU, GPU communication a lot, and you do see some benefits. Varies by game.
Oh, and a comment from Jay Johnson just says, thanks for the live event. Very informative and interesting.
Great.
So,
You're welcome, Jay.
Yes.
Thanks for watching.
Thank you guys for that. I guess, when can we expect the other cards in the 600 series? I imagine you're probably not going to answer that, but there are enough people in there saying that. And
the way to think about it is very simple. We normally follow the same cadence, right? We introduce one card, and eventually the new architecture fills out our whole product roadmap, and that's going to be the same for Kepler as it was for Fermi.
Okay. So you're not going to tell us what you're telling me.
I'm basically going to talk without saying it.
This person says, I love you, Tom Peterson. I want to have your babies.
Wow.
SLI demo, please.
You want to stick it? No. Be good though.
We could turn off the system first. I don't think we have that technology when we just plug it in, right?
No, we don't.
7.1 sound output on it. 7.1 channel through the HDMI.
Yeah,
I assume that's correct.
I assume yes. I haven't tried that myself, but I believe yes on 7.1.
There are future dual GPU card.
That's an excellent question, and for the record, let me say that I don't want to answer that right now.
All right. The people fighting over you in the chat room now too. It's pretty much digressed.
It's bad.
How many polygons in the 100K hair demo?
Oh God, I don't know.
I don't even know.
It's a lot.
The sliders were up there, but they weren't definitive.
Well, it did say 99K hairs, and each hair has many polygons to it. So I think that actually changes as you get fluffier too. So I don't know the exact.
A couple of questions. Are there any instances where a particular processor might bottleneck this card?
Absolutely.
Somebody's asking about the Core i5-2400 that they have in their system. If they put in a 680, is it going to be one of those things where you're not going to see much of an advantage? In my experience, that's not really the case.
It's true. And all the testing I've done, you can see that there are some games that are CPU limited, and then in those games you do see an effect of the processor, but there are very few games that are CPU limited. Very, very few.
I agree.
And as you have higher resolutions, those games tend to be more GPU constrained as well. So kind of depends on your resolution. If you're running at 19 by 10 or greater, then the number of games that have any CPU sensitivity is extremely small.
Okay. Well, I think that's
enough.
I think that's it for us.
All right.
So this, obviously, as the lower third is telling you there, this was the GeForce GTX 680 live review. As it said, we were doing this live. The card launched today.
Yep.
Tom is here
in Kentucky
from NVIDIA, all the way from way out west.
Way out west.
Way out west. He got to experience Kentucky and Cincinnati.
I thought it was great
for the first time.
I'm definitely coming back.
He found a statue of Abraham Lincoln
that he didn't even know existed.
I didn't know existed, but I don't really follow.
But it's right in the middle of the city.
Yeah, but I don't go to Cincinnati that often, I guess is what I'm trying to tell you. So thank you very much for coming out. It's been a lot of fun, and I think we got, a lot of people were watching this. I think we helped things out. I hope you guys found it useful. Obviously go to PCPer.com, go to the homepage, check out our full review where you can get all the benchmarks and all that kind of stuff, and how we compare and performance and power comparisons and that type of thing, and how we stacked up NVIDIA's new card versus AMD's 7000 series. So I guess that's it.
One thing I want to mention, just real quick, is for those of you who don't know, if you check out GeForce.com, there's a few articles about there. We are having a celebration next Wednesday. Next Wednesday, check out GeForce.com. If you get on that site, you can actually register to come. I think there's a few contests. It's very, very small, but we're going to be giving away a lot of prizes. We're going to be having a great event. So check it out on GeForce.com, and please register for the event if you're in the area. It's going to be a lot of fun. And lastly, thanks, Ryan, for having me. It's the first time I've done a live stream like this, and I think it's been really cool.
Yeah, I was just leaning over here to get an update. 1482.
1482.
We might have maxed out our gigabit connection. I'll have to check with the host after that.
But that's really great. And thanks everybody for chiming in. Appreciate it.
Thanks, guys. Follow me on Twitter, twitter.com/Ryan Shrout. Go to PCPer.com/live. Just visit PCPer. You can go to follow PCPer on Twitter or on Facebook. Just add /PCPer to the end, because we're going to do more of these types of events.
It won't be as good, though. Maybe they will.
Maybe they'll be better. We'll never know.
You know what? We might have a new GPU to talk about.
Maybe we'll have another GPU to talk about. Maybe it'll be dual GPU. Maybe it'll be triple. Who knows? We just made all that up. So go to PCPer.com. Check out this review. We've also got the mobile review up there as well of the Acer Aspire Timeline Ultra M3. And thank you, everybody, for watching. And we'll see you next time.
Bye-bye.
See ya. And I just realized that I have no graceful exit to this. I have no little video clip to play while I...
It just ends.
It just ends.
Is it ended yet?
It's still going. We're still going, but see, what we're going to do is we're going to cut this and package it.
I see, except for the people that are watching live.
Except for the people that are watching live, so lucky for them.
Wow.
So that was, all right, that was good. Thanks, everybody.
Hey, thanks, Ryan.
Hey.
Really good. Really good.
All right, here, I'll play this movie again for you, and then we'll
graceful
be out.
exit.
Bye, everybody. You can, if you mute your microphone without turning it off, like there's a button on the top.
Really?
It doesn't introduce all that static.